Hey guys, this is Coach Lowe, and we are going to talk about more proving triangle congruence. We are in section 4 or 5, and we are going to talk about angle, side, angle, and angle, angle, side, using those to prove that two triangles are congruent to each other. So, fun times ahead. Let's get started. So we have two theorems that we would like to talk about. First is actually postulates, postulate 4.3. And it is the angle side angle congruence postulate. And this postulate says if two angles in an included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. And then we know that all parts are congruent by CP/CTC. So let's say that I have triangle ABC here. And I'll go ahead and copy this. See if I can. Let's try that again. All right. So you see that these two triangles are congruent. You saw me just copy that one. So you saw that they are in fact congruent. Same triangle. But let's say that they give us information that angle C is congruent to angle F and angle A is congruent to angle D and side AC is congruent to side FD. Right, so I have angle, side, angle. I have two angles and the side between them. So notice the side that we're talking about being congruent on the triangles is between, it's the included side. So when you see those words, the included side or the included angle, it means the side between the two angles, or like yesterday or with side angle side, the angle between two sides. So that word included, that's what that means. All right, so again, the postulate says if two angles in the included side on one triangle are congruent to two angles in an included side in a second triangle, then these two triangles are congruent to each other. And so we would make a list just like we did with side, 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 and side, angle, side. Angle C is congruent to angle F. Angle A is congruent to angle D, and side AC is congruent to side FD. Um, Therefore, and you guys, and we could put then there also, but we can also use those three dots therefore if you would like to here. Triangle ABC, now be careful when we do this, is congruent to triangle. Now check it out. A and D go together. So we're going to start with D. B and E go together. We know these two are congruent to each other because if two angles in a triangle are congruent to two other angles in a triangle, it forces the third. We learned that a couple of sections ago. So D and E are congruent, and then C and F are congruent. So we want to make sure that we preserve the order and we list this correctly of what is going on between these two triangles. So be super careful about that. This tells us a lot about what's going on up here. We want to make sure that they are saying the same thing. All right, so here's a problem. Let me get some labels on here. This is W, this is R, this is L, E, and D. So L is the midpoint of WE. So let's go ahead and mark. We know if L is the midpoint, by definition, WL and LE are congruent to each other. Definition of midpoint. All right, so we'll come back to that. WR is parallel to ED, so let's go ahead and mark those. I only need one arrow, really. Let's go ahead and mark those parallel lines. All right, so let's see. We're trying to prove that triangle WRL is congruent to EDL. So let's see what we know. Remember, we just came off of angle, side, angle. So since I'm working a little practice problem here, I'm going to push that this is going to be angle, side, angle. So let's see. We know that L is the midpoint. All right, since we know that L is the midpoint, like we talked about just a minute ago, WL is congruent to LE. And why did we say that? We're just going to make some notes over here. Definition of midpoint. Good job. All right, so now what else do you know? Since WR and ED are parallel to each other, if we extend these parallel lines out and maybe get a little transversal going on here, and we could do either transversal, maybe this one right here, we know that LED or angle E and angle W are congruent to each other. Do you guys see that? There's the two parallel lines. Here's my transversal. I have alternate interior angles, don't I? Alternate interior angles, and we know alternate interior angles are congruent in measure. So angle W is congruent to angle E. Alternate interior angles theorem. This is kind of cool. All right, so look what I have now. I have angle, side. Now, if I want to prove this triangle, I need this angle right here. I have angle, side. I need these two angles right. Hey, what are those two angles? Yeah, those two angles are vertical angles. We know they're congruent, don't we? This is awesome. All right, so angle RLW is congruent to angle ELW because vertical angles are congruent. Whoop, whoop. All right, so I have angle, side, angle. So I have this angle W is congruent to angle E. I have the side that's between them, and then I have vertical angles here. That means the triangles are congruent. So we are finished. We have just proven triangle WRL is congruent to triangle EDL by angle, side, angle postulate. Awesome. Okay, now I don't mean to scare you here, but we just did a column proof. We didn't write down the given, but it is up here. We just wrote a two-column proof, guys. How about that? Statements, reason, given, given. We can add those two at the top. This is where we're going, so that doesn't go with our two-column. That's just what we're focused on. Awesome. Congratulations. High five. All right, let's talk about another one. Let's talk about angle side. And before we get to this, let's talk about the angle side postulate. All right, this is theorem 4.5. So angle side congruence. All right, so we had postulate 4.3 with angle side angle congruence. Now we have theorem 4.5, angle side congruence. So now we have two angles in a row and then a side. So the side's not between them, it just follows it. All right, so let's get a little picture real quick like here. All right, so you can probably guess how to do this, and if you want to pause the video and do it yourself and see if we match, do it, please. That would be awesome. All right, triangle ABC, triangle DEF. All right, angle side. Angle C is congruent to angle F. Angle A is congruent to angle D. Angle AB would be congruent to angle DE. That would be the setup. If you see this, angle, side, the triangles are congruent to each other. Now, here's the cool thing. We kind of already know that because if we have two angles congruent to each other, we know the third is. And once we get that side, we are home free. So that's awesome. All right, so let's do this problem. You're given here angle NKL is congruent to angle NJM. All right, then it says KL is congruent to JM. So let me mark that. KL is congruent to JM. All right, do you see the triangles here? You see the two triangles here. All right, so we have angle, side. We could get angle here. That'd be angle, side, angle. Or maybe get this angle right here because we'd have side, angle, angle, or angle, angle, side. All right, so these are given. All right, do you see something weird going on here? Angle N is common to both triangles. Do you guys see the different triangles? Let me trace them. That might be helpful. There's triangle number 1 in question. So JNM. And here's triangle number 2 that we're talking about. So KNL. KNL. Do you see something in common? N is in both of those triangles. Well, N is congruent to itself, isn't it? I mean, it's the same measure, whether it's in the green triangle or the yellow triangle, same measure. All right, so my statement would be angle N is congruent to itself. Wait, what? What property is that? That's reflexive. So by the reflexive property, we know that angle N is congruent to itself. Angle N being congruent to itself solidifies angle, angle, side, angle, angle, side. Hey, we're through. So let's get this right. Make sure we get it in the right order. J and K go together. All right, I have that. N and N go together. That means M and L go together. So we have it in the right order. So triangle JNM is congruent to triangle KNL, and that's by angle, angle, side. All right, that was just a couple of examples and our theorems. Now, listen, we have several things going on now. We have side, side, side. We have side, angle, side. We have angle, side, angle. And we have angle, angle, side. We'll make a list of those and solidify this when we get back together soon. So until then, have fun with math. This is Coach Lowe, and I'm out.